Good morning, class. Today we're going to do lesson number 14 on calculating discounts and markups. So discounts are where you're going to save a certain amount of money, and markups are where it's going to cost you a bit more than the actual sale price. When we talk about like a sale price or a percent sale or percent markup, we're saying if you see like, oh, we get 25% off this item or up to 75% on this rack or whenever you go shopping, or it could be you got taxes on whatever you buy. So sometimes you'll have 5%, sometimes you'll have 12%. Depends on what you buy, or sometimes you have no taxes. So it's calculating how much the item will really cost you after taxes. Or it could be saying if I am selling things, let's say I buy a bunch of books for like $10 each, I'm able to sell them for like $15 each. We can calculate the percent markup I have on those items, and then we can also calculate the percent revenue I'm getting as well. So there's lots of different things we can do in this chapter, but today we're going to focus on more just the basics so we can kind of get our heads wrapped around it, and then on Friday we'll look more at some of the more interesting ideas. So first off, if we have a chair, I couldn't think of a better thing to buy, so we're buying a chair and it's going to cost us $100. It's an expensive chair, it's a fancy one. I guess it could be like a lounge chair. Those cost about $100. Anyway, so you buy a chair for $100 and you pay $100 for it. You're going to be paying 100% of that price because you're paying the full thing. So even if it costs $200, you pay $200. You're still paying 100% of that price. So it's going to cost you. You're paying everything. You're not getting any discount or anything like that. So if we're going to say you find the same chair, same price, but now it's on sale for 20% off. So how can we calculate how much this chair is going to cost you if it normally costs $100, but we get 20% off? Now, there's two ways to look at it. They're both essentially the same. It's just you do calculations in different order. So let's look at way one. So we're going to say, okay, we have $100, and now we're going to get 20% off. So that keyword off, so you're going to remove it. So we're going to have a minus. We got $100. We're going to minus 20% of that price. So we get 20% off of that full price. So with our percent, when we want to do a calculation with it, we're going to change that percent into decimal form. Now we do this by dividing by 100. Another way to say it is we just put 0 point and then whatever percent we have, as long as the percent is under 100. If it gets over 100, which we'll talk about in a second, it gets a bit trickier. So in this case, we just have 20%. We can divide by 100, or we can just make that 0.2, same thing. So that's going to be the percent in decimal form. And it's going to be 0.2 times 100. That's the price of the object. So it's the percent in decimal form multiplied by the price of the object. So we can see we have $100 minus $20. So we're saving $20. And what we're going to end up paying is going to be $80. So when you get 20% off, you're just removing that 20% of the price from your price you're paying. Sorry about that. The second way that we can do this is, instead of doing the calculation on 20% of the full price, we can just do that percent calculation of how much we're actually going to pay. So if we get 20% off, then instead of paying 100%, we go 100% minus 20%, and we end up paying 80%. So we do the subtraction first. So we say, okay, now we're going to pay 80% of the price. That's going to be 100% minus the percent we save. So 20% gives us 80%. So we are going to have to pay 80% of $100. So the 80% we convert to decimal form, being 0.8, multiplied by the price, the original price. So multiplied by the $100. And that again is going to give us $80. So both ways give us the same answer. Way two, we just do the minus first. With way one, we do the multiplication with the percent first. So we figure out how much we're saving first instead of how much we have to pay. So it's totally up to you which way you prefer. I wanted to show you both ways. I think it gives you a sense of larger idea of what we're actually doing in the math. It doesn't matter which way we do it, but what we're trying to do is figure out how much percent off we get. So we can figure out how much percent off we get first, or we can figure out how much money we get off. Both work. So I find method 2 a bit easier if I'm doing mental math. So next class we'll touch on this. If I'm in the store trying to figure out how much you're going to save, it's a bit easier if I do way 2, but that's how my brain works, and your brain might work very different. I've noticed more and more that the way I do math is interesting sometimes. Okay, so let's look at, instead of looking at like a percent discount or sale price, let's look at percent markup. So taxes are a thing on everything you buy, and when you go shops in North America, the price you pay does not include the price, like on the price it shows is not how much you're going to pay because they had taxes on it. Where in Europe, a lot of the time, from my understanding, is you go and you pay, and the price it says on it is how much you pay because the taxes aren't included. I don't know why we don't do it here this way. It doesn't make sense to me because then you have to guess how much you're going to pay. But we can actually calculate it before by doing it this method. So let's say we have the same chair we pay $80 for, or we're going to pay $80 for it. That's how much they say it's going to cost. We go to the cash register, we pay, and they're going to add 12% sales tax on it. We want to figure out, before they tell us how much we're going to pay, let's figure out how much it's going to cost us. So we paid $80. That's how much it says we got to pay, plus the 12% of the sale price. So again, this is method 1. We're going to find the price we have to pay, and we're going to add it this time to that $80. So we're adding because this is a markup. So we're going to increase the value because we're going to add the sales tax onto our cost. So instead of it being 20% off, it's 12% on, essentially. So we're going to plus 12% of the sale price. This is going to be converting our 12% into a decimal form, so 0.12, multiplied by the sale price. That's how much we're actually that's how much it says on the ticket, how much it costs, so $80. And this is going to give us 80 plus 9.6, or $9.60. And that's going to give us a total of $98.60 for the cost of this chair. In method 2, what we're going to do, just like we did last time, we're going to add the percents up first. So we pay 100% of the $80 plus 12% of that $80 for the sales tax. So we can add these percents together, and this is going to give us 112%. So this is how much of that sale price we have to pay because of the taxes added onto it. So here we got $80 times 112%. And now when we convert this, because it's over 100%, it's actually 1 point. So instead of that 0.12, it's 1.12 because we added 100%, which is essentially, so 100% is 1. And then, like, if you go below 100%, you got 0. Whatever percent you have. If you have above, it's 1 point whatever percent you have. So here, 80% times $80 times 1.12. And doing that calculation, we get the same value of $89.60. The secret word of the day is going to be ice cream cone. So again, both ways are completely valid. It just depends if you prefer to find the total percent you got to pay first, or if you want to find how much you have to add on or subtract. So both ways are completely valid. Okay, so the last thing I want to look at, this one might be a bit tricky, so we're going to touch on this again next class. So finally, let's look at the percent discount or percent markup. So how do we find how much we're saving, or how much is going to how much of the price can we marked up? So we can find both in one formula. So the percent markup or discount is going to be 100% minus 100 times the sale price divided by the original price. And that's going to be the percent. So we multiply by 100 here so that we're instead of getting it in decimal form, we're going to get it into percent form. So 100% minus 100 of the sale price divided by the original price. And that is going to be a percent as well. So if it's a sale, if the sale price is going to be more than the original price, so like what we saw in the last example, we had to pay taxes. It was $89 or $89.60, and the original price was just $80. Our sale price is going to be higher than original price, so this is going to be a markup, and we're going to get a negative value for a percent markup. We get negative 12%. And what that negative means is that you have to pay more. So when we talk about percent markup, we can ignore that negative, but that negative is really going to tell us that it's a markup, that we're paying more. So we'd still have 12% markup, but negative sign is going to tell us that it's a markup. If the sale price is less than the original price, what we're going to get is a positive value, that is the percent that you save. So if you looked at the first example we did where we saved 20%, the percent discount would equal positive 20%. So positive is good, you save money, negative is bad, you pay more money. That'd be one way to think about it. Okay, so let's look at one example. So let's say you buy a car for $25,000, $430. $25,430. Okay, and initially you got a good deal. The car was going to cost you $32,000. And we want to figure out what percent discount did you get. So we're going to use our formula, 100% minus 100 times the sale price over the original price, and that's percent. So this is a really good formula to have. So we're going to be using it a couple times. So kind of make sure you write it down somewhere, or make sure you know where to find it. So we put our sale price in of $25,430, and our original price of $32,000. We do the division in here, and this is going to give us 100 times 0.795, and that's going to be percent with the multiplication by 100. So it's going from that one. By multiplying by 100, we go from decimal form to percent form. So now we got 100% minus 79.5%, and this gives us a discount because it's positive of 20.5%. Is how much we're saving on that car, which is a great amount to save on a car. Okay, so let's look at a percent markup now. So let's just say you buy a burger that's listed as $10 and you pay $11.20 for it. I'm going to figure out what percent markup you pay. So again, we put in 100% minus 100 times the sale price of $11.20 divided by the ticket price of $10. And this is going to give us 100% minus 100 times 1.12. So you may notice that's going to be like 112%, which is essentially how much you have to pay when you add taxes onto it. So we got 100% minus 112%, giving us negative 12%. So that negative means you pay 12% more. So we remove the negative sign when we say you pay negative 12% more, but that negative sign just tells you pay 12% more. That more is from the negative sign. So that's it for today. Again, next lesson we'll look at the same idea, just more kind of the mental math side of it. There's 3 problems for you to do. Problem 1 and problem 3 have multiple parts, so I just did 3. So problem 1 on page 165, and there's like 4 parts, and then problem 2 and problem 3 on page 166. So that will be in problem set number 14. The numbers again, that's a lot of problem sets and give me, I think by the end of the year, we'll probably get to like 24 maybe, which would be lots for you to do. So I appreciate everybody. I found that the engagement has increased. People are putting the effort in. So it's great that you're doing that. Keep up the good work. I know that people are in very different circumstances and it might be really hard for some people. So if you're feeling like you're struggling to catch up or you're struggling with it, please reach out to me. We got you got me, Carmine, Mr. S, and Kim available for help. And we can even work on ways to get you caught up. So if you're feeling like you're behind and you feel like you don't know what's going on, please reach out. All right, have a good rest of the day. See you next time.